Welcome to the Eternal Bright Light channel. Year 1687 AD. Sir Isaac Newton published his 3 laws of motion. These 3 laws laid the foundation for classical mechanics. This discovery proved to be very significant in understanding how the universe operates on a macroscopic level. But before we get to these 3 laws, first we need to understand the meaning of some important terms used in physics. Let's first understand about the term mass. What is mass? Mass is simply the quantity of matter present in a physical body. Mass is also the measure of inertia of a physical body. Now, what is inertia? Inertia is simply the tendency of a physical body to resist change. Also, mass is directly proportional to gravitation. The more mass an object has, the more will be its gravitational force. The SI unit of mass is kilogram. Next, let's understand the term velocity. Velocity is the displacement of the body per unit time. Displacement is the difference between the final and initial position of a body. Unlike distance, displacement can be 0 if the final and initial position is the same. That is, if the body is moving in a circular path, its displacement will be 0, however, its distance will not be 0. Therefore, velocity of an object can be 0, even though its speed is a positive value. Hence, velocity is a vector quantity. That is, both the magnitude and direction is taken into consideration while calculating velocity. In a given figure, velocity will be a positive value as it is moving in a straight line. The SI unit of velocity is meter per second. Next comes acceleration. Acceleration is simply defined as the rate of change of velocity with respect to time. Suppose a body was initially having a velocity of v1 at a time t1. Then, it changed its velocity to v2 at a time t2. Then, the acceleration of the body is the difference of its final and initial velocity, divided by the time difference, which is the time it took to change its velocity from v1 to v2. So, in simple terms, acceleration means the velocity of the body keeps on increasing with the passage of time. But acceleration can also be negative. This happens when the body in motion is gradually slowing down and ultimately comes to rest. Here, the velocity of the body keeps on decreasing with the passage of time. Hence, it is called negative acceleration or retardation. The SI unit of acceleration is meter per second square. Now, let's talk about force. Force can be defined as an influence that can change the motion of an object. That is, an object with mass can be forced to change from its state of rest to motion, or vice versa. Force is also a vector quantity, and has both magnitude and direction. The direction from which the force is acting is equally important to the magnitude of the force acting on a body. The SI unit of force is Newton. Now that we understand these basic terms, let's move on to the 3 laws of motion discovered by Sir Isaac Newton. The first law states that an object at rest will remain at rest, and an object at motion will remain in its state of uniform motion, unless acted upon by an unbalanced external force. This simply defines the inertia of the body. Inertia is the tendency of the body to resist change, whether it is in rest or motion. Which means, a body in rest will resist when a force is trying to make it to move, and vice versa. So, this law is also called the law of inertia. This law helps to predict the behavior of an object at a macroscopic level. However, there is one important criterion. That is, the force must be unbalanced. So if multiple forces are acting on the object, the net force should not be zero. We already know that force is a vector quantity, where both the magnitude and direction comes into play. For example, in the given figure, there are two forces acting on the body, of equal magnitude. But their direction is exactly opposite to each other, which results the net force to be zero. Therefore, the body remains in its state of rest, in spite of multiple forces acting on it, as the net force is zero. The second law can be stated as, the time rate of change of momentum of a body is equal in magnitude and direction to the force imposed on it. Momentum of a body is defined as the product of its mass and velocity. So, consider a body having a uniform mass m, with an initial velocity of v1. Hence, its initial momentum is mv1. Now, an external force is applied on it. So, it changes its velocity to v2. Now, its momentum has changed to mv2. Therefore, the change in momentum of the body is mv2 minus mv1. But that's not all. The law states the time rate of change of momentum, and not just the change of momentum. So, we also have to consider the time difference as well, that is, the time it took for the body to change its momentum from mv1 to mv2. But we also know v2 minus v1 divided by t2 minus t1 is nothing but the formula for acceleration. So, we can write the equation as F equals to ma, or force is mass times its acceleration. There is also a special case of this law, where the mass is not constant. In that case, there will be a slight modification in the equation, but the basic concept will still remain the same. Now, let's move on to the third law. The third law is probably the most commonly heard of and famous as well. The third law can be stated as, to each and every action, there exists an equal and opposite reaction. This simply means, when two objects interact with each other, they also exert force on each other. Here, forces are considered as a pair, acting simultaneously on each other. However, the direction of the two forces will be opposite to each other. So, forces always come in equal and opposite action-reaction force pairs. For example, when you jump, you exert a force on the ground in return exerts an equal reaction force, but in opposite direction. It is this reaction force which helps you momentarily rise from the ground level against the force of gravity. The same principle is used today in the lifting of rockets as well. Now that we understand these three laws, but what is the significance of these three laws? These three laws of Sir Isaac Newton paved the way for the foundation of classical mechanics. They were discovered nearly 400 years ago, at a time when the world was completely different from what we see today. It helped to answer many questions and unravel many mysteries of the universe. These laws were a revolution, which completely changed our understanding of the universe. But not just these laws, Sir Isaac Newton also contributed massively in many other fields of mathematics and physics as well. But we will discuss about them another day. If you liked this video and found it helpful, then please share it with your friends. More exciting contents are coming. So stay tuned and subscribe to the channel. Goodbye. See you soon.